Our next speaker for the day is Auden Krauska. Auden is a PhD student in the Department of Statistics at University of Wisconsin-Madison, and Auden will be speaking on in systematic reviews, less than 10% of randomized controlled trials in biomedical research are good experiments. So let's welcome Auden.
All right. The title is kind of the punchline of the talk. I took a random sample of biomedical research, and I found that less than 10% of randomized controlled trials are what systematic review authors call good experiments. So just to kind of orient you a little bit, it's kind of a hand-wavy definition, but systematic reviews, generally speaking, have a meta-analysis, which is something that puts together a ton of randomized controlled trials. We all know that if you look at just one randomized controlled trial, if the null hypothesis is true, there's a 5% of chance that it would get a statistically significant result if you pick that significance level. So we don't want to just look at one randomized controlled trial. So systematic review authors look at 10, 20, 100, 500, however many there are, randomized controlled trials, and boil it down into one. And when they do that, they're going to find some randomized controlled trials are good, and some of them are not. Some of them are going to do really well in how they choose to blind participants, right, to make sure that participants don't know whether they're receiving treatment or control. Some of them are going to have major issues with like a third of the patients decided to drop out. And maybe that dropping out is going to be systematically different as well. That can introduce bias. So some researchers in Cochrane developed the Risk of Bias 2 tool, the ROB2 tool, that has 5 different domains for what they call a good experiment. So the first one is the allocation of randomization. Right? It's not a randomized control trial if you didn't adequately randomize your patients to treatment or control. The second domain is looking at deviations from intended interventions. And this is essentially just saying, did you do an intention to treat analysis appropriately? Next, we're looking for missing outcome data. Like I said before, if we have a systematic difference between maybe people who are doing more poorly, maybe people who don't feel like their treatment is effective, they're leaving the study, and we're left with a systematic difference between people who stay and people who don't, and that also falls along the same lines as treatment and control. That's going to bias our results. Next, we want to look at the measurement of the outcome. We want to make sure that there aren't any systematic differences between treatment and control. This is especially common if we randomize some people to treatment, and those are the people that we're actively bringing into clinic and measuring their outcome. And then everybody else, we're just kind of getting from their electronic health records. The way that we're measuring the outcome in those two situations is different, and that can introduce bias. And then lastly, I don't think I need to reiterate the selection of reported results and the publication crisis. The last domain is looking at evidence for, did you actually look at 100 different outcomes and now you're just reporting the one that was statistically significant? So I took a random sample of systematic reviews that were published under the British Medical Journal umbrella, so BMJ Open, BMJ, all of them. And I found 31 systematic reviews that specifically used this ROB2 tool. And then we went through and looked at the appendix or the supplemental material to find all of these kind of plots that you see here, where it has the risk of bias and then the score for each of those domains. So the score you have here in green is a low risk of bias. Yellow is the middle of the road kind of some concerns category, as they call it. And then the red is your high risk of bias. So looking at these 31 systematic reviews, that accounted for 1,102 original research articles, or original randomized controlled trials. And from that, we found in our sample that 7% of the original research articles are at a low risk of bias. If we want to think about the 31 systematic reviews as a cluster sample, we can see that 8% of the randomized controlled trials are at low risk of bias. 28% of the original articles, or 31% of the cluster sample, are in that kind of medium category, some concerns. And then roughly 2/3 of the randomized controlled trials are at high risk of bias. I find this absolutely astounding. Additionally, there were 42% of the systematic review authors explicitly commented on how underreporting, so not telling us enough information, how that contributed to them downgrading the quality of a study. And if we specifically look at those articles where they commented on underreporting per paper, we see that that accounted for 66% of original research articles that were underreported. If we think about all of the steps and time and effort and money that go into creating a randomized controlled trial, and I would want you to tell me all of those steps, right, of how you went through the randomization, right? What were all of the things that you did in order to get the random number generators or envelopes, whatever it was, and all of that information, if you don't report it, I don't think we really can believe that the randomization process was done correctly. And so therefore, we just end up downgrading the quality. So thinking about all of the money and effort that goes into a randomized controlled trial, all of the doctors that spent time caring for their patients, all of their patients who got an experimental treatment, maybe it wasn't the highest quality treatment, all of the peer review and editors and times that the academic literature has spent for all of these things, and it all goes to waste because they didn't report the information that they should have. And so then it's just downgraded in quality. So thank you so much for your time. I can take questions.
Thank you so much, Auden. Do we have any questions in the audience?
Yeah, great. So 2 questions. One is, how did the meta-analysts treat it? Did they exclude them? And 2, what percentage of the total sample size of the meta-analysis was of low quality? The number of studies, sometimes it's the smaller studies that, I mean, I don't know what happened in this sample, but as studies sort of migrate up the food chain as it evolves in a particular area, sometimes they get better and they're published in better journals and they get bigger. So, basically what percentage of the total information was of the poorest quality or of unknown quality?
Great question. So we were specifically looking at the ROB2 guidelines that were developed by Cochrane. And under PRISMA guidelines, the ideal is to never exclude randomized controlled trials for low quality. You're supposed to kind of report the information separately, but ideally you never exclude a study entirely just because you think that it's at high risk of bias or that there's some other information. So I didn't find any evidence that there were any excluded, but certainly, I just have to trust that they were reporting all of the studies that they found. There certainly could be some that they just excluded and didn't write it up at all. And then to your second question, I don't think that the way that we sampled systematic reviews written in the BMJ umbrella of journals, I don't think that we would have been able to see that kind of iterative process to things kind of floating to the top.
No, what I meant was you have 60% here are rated poor.
Yep.
But what percentage of the actual total sample size of the meta-analysis did that represent? That could be 5% of the total number of subjects that were included in the, I'm not saying it's that low, but how much of the information was, as opposed to the number of studies, were rated low?
I'm not sure if I understand your question. So I've broken it up by just if you look at every single randomized control trial in the 31 systematic reviews, that's on the left. And if we think about the percentage of high risk of bias studies per study, and then you just average kind of an unweighted sample, I guess, by a systematic review, then you'd see that it's 60%.
Okay, maybe we'll talk later. But
yeah, I would love to talk with you offline. Yeah.
So a lot of fields have reporting standards that would try to drive you to report all the stuff you need. Are these fields that don't have those standards, or are they just not being followed?
Ironically enough, these are all studies also that declared PRISMA. I haven't finished going through all of the PRISMA results, but I'd say that the reporting adherence for these studies was roughly 60% for PRISMA. To clarify slightly more for others, there are reporting guidelines for randomized controlled trials in the biomedical literature. It's called CONSORT, and it goes through and it lists all of the very basic information that you would need to know in order to understand a randomized controlled trial. So like, who's in your study? Who is allowed in, who wasn't allowed in? Those are called your eligibility criteria, your inclusion and your exclusion criteria. And a lot of the time it's not reported in randomized controlled trials. And then beyond that, even these people that are commenting on how randomized controlled trials don't adhere to reporting guidelines, they don't adhere to their own reporting guideline, which is that systematic reviews should also follow a set of reporting guidelines called PRISMA that go through and kind of lay out, like, how did you do your systematic review? The very basic information that you would need to know in order to evaluate it.
Thanks.